These are notes for acids and bases, worksheet number 2. Polyprotic acids. Poly stands for many, so it means it has many acidic parts. So acids that can transfer more than one H plus ion. There's 3 types. There's monoprotic, which have 1 H. There's diprotic, which have 2 H's. And there's triprotic, which have 3 H's. Strong acids and strong bases. So SA stands for strong acid, SB stands for strong base, can donate 100% of their H plus ions or their OH ions, depending if they're an acid or base. This means that they have 100% dissociation. To dissociate means that they break up. So if you had 100 HCl molecules, that would mean 100 of your H's break off in solution and become very acidic. So the big 6, the strong acids, there are only 6 strong acids. They are HClO4, HI, HNO3, HCl, HBr, H2SO4. The rest of them are weak acids. Those taking the AP Chem class next year have to memorize these. Remember, Penn CBS, this is how I remember it, where P stands for perchloric, I stands for hydroiodic, N stands for nitric, C stands for chloric, B bromic, S sulfuric. All other acids are weak and need to begin lifting their weights. Strong bases. In general, there are these strong bases. Any metal from group 1 with an OH, and these metals in group 2, calcium, strontium, barium. They tend to be strong bases. A weak acid or base does not dissociate or ionize 100% or completely. They tend not to be as strong of an acid or a base because of that. For instance, if you had 100 molecules of HF, perhaps only 75 of them will give up the H+. This means that HF has a 75% dissociation rate. 25% of it doesn't dissociate. Weak bases. In a weak base, the cation has a higher attraction for the OH than water, so the OH tends to stay attached to its cation, thus less than 100% dissociation. For example, copper hydroxide is a weak base. Amphoteric, one of my favorite words. What? Amphoteric means that a substance can act as an acid or base by accepting or transferring a proton. Water is the most common amphoteric substance. It can be an acid or a base. This is called autoionization of water. So water as an acid or base, which means the autoionization of water. So here's water. Water and ammonia. And in this case, let's take a deeper look. So here, water is associated with that, and ammonia is associated with ammonium. So from here to there, the water lost an H, that makes it an acid. But and this one from there to there gains one, that makes it a base, that makes it the conjugate acid, that makes that the conjugate base. Isn't that nice? Let's look at the next one. Oops. So there, water, the first one, water acted as an acid, and this one, water is going to act as a base. Let's check this out. So we find the pairs. Oh, don't give up on me. So HNO3 looks like this one, so those ones are together, and there's the acid because it gives up the H, and here water acts as the base because it gains an H. That makes it the conjugate acid, and that one makes that one the conjugate base. So here water is acting as a base, and up above it's acting as an acid. Very strange, but possible. pH, Ph. pH represents the power of hydrogens. It is a logarithmic calculation. What does a pH of 7 mean? Hopefully you know that it means something's neutral. Substances that have a pH less than 7 are acidic. Substances that have a pH greater than 7 are basic. Examples of pH. pH less than 1 is battery acid. pH equal to 1 stomach acid. 2 vinegar, lemon juice. I'll let you keep looking through these. More pH. 8 seawater, 9 baking soda, 10 Salt Lake, 11 ammonia, 12 soapy water, 13 bleach, 14 liquid drain cleaner. Oh, it just got worse and worse. So brackets mean concentration. A bracket around OH or H plus represents the concentration of either ion in an aqueous solution. We must learn about the concentration of OH and H plus before we can do pH calculations. So now we're going to do the autoionization of water that we talked about a long time ago. 2 water molecules together. So the first one acts, you could choose whatever one, but I just chose this one to be the acid because in this case it loses an H and has a conjugate base. In this case, it gains an H and has a conjugate acid. Oh, I need to get some rest. Those double-headed arrows represent an equilibrium, which means this reaction goes back and forth from products to reactants. From here on, we'll use H plus instead of H3O for simplicity. Water is neutral, or it should be neutral, because the concentration of the acid and the base parts are equal. So the acid parts equal the base parts. 3 different possibilities. You're neutral if your acid equals your base. You're acidic if your acid is greater than your base. And you're basic if your base is greater than your acid, or your acid is less than your base, however you want to look at it. So it has been proven that the concentration of H plus is 1 times 10 to the minus 7th molar, and the concentration of OH is 1 times 10 to the minus 7th molar. Remember, M is the molar concentration. Now multiply the two together, and what do you get? Bada bing, 1 times 10 to the minus 14th, because you're really just adding exponents. So I hope the numbers 7 and 14 ring a bell for you. 7 is neutral, and 14 is the end of the pH scale. So here's the equations that we're going to use. H plus times OH minus is 1 times 10 to the minus 14th. If you want to solve for OH, it's 1 times 10 to the minus 14th divided by H plus. If you want to find H plus, it's 1 times 10 to the minus 14th divided by OH minus. So let's do problem number 5b from worksheet 2. 5b. Find the concentration of OH if the H plus is... I don't know why my pen's just not working today. If the blah, 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 blah. Find the OH minus if the concentration of H plus is 7 times 10 to the minus 7th molar. Is this solution acidic or basic? Oh, I need a nap. If I say that again, you're probably going to get frustrated. So what do we know? We know that we're trying to find OH minus. And OH minus equals 1 times 10 to the minus 14th minus 14th divided by the concentration of H plus. Oh, we got all those things. We can do this. Sweet. So we're going to go 1.00 times 10 to the minus 14th. I'm so tired I can't even write my numbers correctly. Divided by 7.00 times 10 to the minus 7th. And what do we get? Bada bing. We get 1.43 times 10 to the minus 8th molar. That's the concentration for H plus, or the OH minus. There you go. Oh, and it asks us, is the solution acidic or basic? The solution is acidic because the acid parts are greater than the base parts. Those are the notes for worksheet 2.